Hello, everyone. So yeah, we have another question that one of our students have given us. They ask us to evaluate. It's a calculus question. It says evaluate the limit. Okay, as we see, the expression is the limit as x goes to a of the square root of x minus square root of a over 9 times x minus a. Now, this is a rational expression because you have one expression in the numerator divided by another expression in the denominator, right? In addition, in the numerator, we have two terms, right? Terms are separated by plus, minus, or equal sign. So one term is square root of x, the other term is square root of a. Right, so the way we deal with this is we see that if we plug in a, we're going to end up with 0 in the denominator, right? And we don't want to do that. So the way we're going to deal with this is we're going to multiply the top and bottom. Now, if you look over to the right, you'll see what I'm talking about. It says technique here. This is where we're focusing right now. We're going to multiply the rational expression by the conjugate of the numerator, right? So the numerator expression is square root of x minus square root of a, right? The conjugate of that is just it's just changing that sign in the middle. So the conjugate will be square root of x plus square root of a, right? Now that we know what the conjugate is, we're going to multiply both the top and bottom by the conjugate, and then we're going to simplify, and then we'll be able to evaluate the limit. Okay, so let's go ahead. So here you see we're right here now. We're doing step one. We're multiplying by the conjugate, right? And the reason we can do this is because with any number divided by itself is 1, right? So multiplying by the top and bottom by the conjugate, which is the same expression, is the same as just saying, starting from the original equation and just multiplying that by 1, right? So if we multiply square root of square root of x over square root of a over 9 times x minus a times 1, we're not changing anything, right? So in step 1, we multiply the top and bottom by the conjugate. If you simplify the conjugate, it equals 1. So we're still not changing anything, right? So that's why this step is allowed. So we go ahead and multiply out, right? In the denominator, we're not gonna operate on any of the variables. We're gonna leave it just as is. It's gonna be 9 times x minus a, right? Times square root of x plus square root of a, right? In the top, however, we're going to use a technique called FOIL to multiply these two binomial expressions. Now, why I call them binomial expressions? Because there are two expressions that each have two terms, right? The one on the right is square root of x minus square root of a. That's two terms. And the one on the left is square root of x plus square root of a. That's two terms. Whenever you have an expression with just two terms, that's called a binomial. So we're going to multiply these two binomial expressions, and we're going to use a technique known as FOIL. Now, what this is, it's an acronym, right, that lets us know which terms to multiply each other by whenever we're multiplying two binomial factors, right? If you look up here, you'll see that FOIL represents the term. So F is the first terms, O is the outer terms, I is the inner terms, and L represents the last terms. And here's an example right here of how it works. If we have two terms, two binomial terms like this, one is x plus 2 and one is x plus 3, we multiply them, we're going to multiply according the variables according to what FOIL says. So we're going to multiply the first. So the first term is going to be the x and the x. So it's going to be x times x. Then we're going to multiply the outer. The outer terms are going to be the x on the left and the 3 on the right. 3 times x gives us 3x. That's what we have here, right? Then we multiply the inner. The inner is going to, excuse me, the inner is going to be 2 times x, right? And 2 times x is 2x. That's what we have here. And then we multiply the last together, right? So the last terms are 2 and 3. So 2 times 3 will give us 6, and that's this term here. And once we do that, we just combine like terms. We simplify. So we get x times x gives us x squared. 3x and 2x are like terms. We can add them together to get 5x. And then we have the other term, 6. That's by itself. We just bring that down, right? So this is an example of how we use the FOIL technique to multiply two binomial terms. So we use that same technique to multiply these two binomial terms. And this is what we got. We got square root of x times square root of x minus square root of a square root of x plus square root a square root of x, right? Minus square root of a times square root of a. And when you simplify that, what you get is x minus a in the top, and then everything else that we had on the bottom. Now, at this point, we're looking to simplify this further, right? That's step 2. Step 2 was simplify. And we notice that we have a binomial term at the top of x minus a right here, right? And then we also have a binomial term in the bottom of x minus a. So we can cross those out. Whenever we have matching terms or matching binomial terms, the top and bottom, we can cancel the whole thing. So these two cancel out to 1, right? And then we're down to just 1 over 9 times square root of x plus square root of x. Okay. At this point, we can't simplify anymore. So we're going to go ahead and do the last step, which is to evaluate the limit with our simplified expression. And everyone knows to do that, we're going to evaluate at a. So all we do is whenever we see the variable x, we're going to plug in a. And that's what we've done right here. We plugged in a. And then now we notice that we have, again, two like terms. In the denominator, we have square root of a plus square root of a, which just simply gives us 2 square root of a. And we have 1 over 9 times 2 square root of a, which 9 times 2 is 18, so we end up the answer being 1 over 18 times the square root of a. Okay, so I hope this helped. If it did, please remember to like and subscribe, and I will see you on the next question.